All right, section 2.3, problem number 45 is a word problem where we have an ant marching up a hill such a way that its altitude is a function of its distance from the peak of the hill, and its distance from the peak of the hill is a function of time. So see that have altitude is dependent on r, which is, the distance, which again is dependent on t. So you can see that we have a composition of functions and are going to likely have to use the chain rule. Now, part A asks us to find the derivative of a with respect to r, the distance from the peak, given that the distance from the peak, the rate of change of the distance to the peak with respect to time is negative 0.5 centimeters per second, and the altitude of the ant is increasing at 2 centimeters per second. So we see that from the chain rule, if we write this using this notation here, so dA dt is equal to dA dr times dr dt. We know that the altitude is increasing at 2 centimeters per second, so the rate of change of the altitude with respect to time is equal to 2. Now, we're also given that dr dt is equal to negative 0.5 centimeters per second. So we can rewrite the right-hand side as dA dr, which is exactly the quantity that we're looking for, times negative 0.5 centimeters per second. So if we go through and solve this for the unknown quantity dA dr, that dA dr is equal to 2 over negative 0.5, which is equal to negative 4. And for part B, we're asked to find the derivative of the altitude with respect to time. So now we're looking for dA dt, and we're given that dr dt is equal to 0.9 and dA dr is equal to negative 0.7. So if we just plug into the formula that we've earned the chain rule here, which we've already written out, we see that dA dr is, well, negative 0.7. And dr dt we're given is 0.9. So we see that the derivative of a with respect to time will be equal to negative 6.3, and this will be centimeters per, 0.63 centimeters per second. And that's the end of problem number 45.